Okay, so we have a 0.5 kilogram ball. Oh, and look, I'm going to solve A. I'm going to show you how to do. I'm going to show you how to do this, part A, which is totally appropriate level for this course. Part B and C, I'll show you the setup, like how to get the physics part done. The math that is going to be required is it's way too complex, as you'll see in a minute. So part A would be quiz level, definitely midterm level. Questions B and C, I would never give that to you, nor would the College Board. Those are too hard. So part A is what I want to talk about. So we got this ball. The mass equals 0.5 kilograms. It's tied to the end of a, so the length of the string here is 1.5 meters. That's not the force. Okay, I've given questions like this on midterm exams, you know, where I'm grading the work. And when kids do their free body diagrams, they're like, okay, there's the ball. We have a force this way, which is 1.5. Look, is the 1.5 the force? No, that's not the force. Okay, what else do we have here? So the length of the string is 1.5. This theta right here is 30 degrees. Theta is 30. And what else do we have? The ball is, I think that's it. Okay, what's the radius of this circle? The center of the circle is right here. This dot right there, you know, this mass is rotating around in a circle. The center of the circle is not the person's hand. That's not the center. The center is right there. Center of the circle is always positive, but what's this radius going to be? How do we solve for the radius of the circle? Trig. So the radius of the circle is going to be equal to sine 30 times 1.5 meters, which comes out to be 0.75. Okay? So the radius of the circle, we solve for it with trig. It's 0.75 meters. Okay? All right. The question is, determine the ball's speed, which is tangential. It's a tangential velocity. If this ball left the circular path, how would the ball leave the circle? In a straight line, tangent to the circle, right? All right, so the way we solve this is we do free body diagram for the ball. So what are the forces on the ball? Here's the ball right here. What are the forces on that ball? mg down, and then tension is at an angle. Okay, tension's at an angle. Now look, this problem, they're giving us the angle with the vertical. So let's just do that, because we could switch it and make it from the horizontal. So the angle they're giving us is up here. That's 30 degrees. So I'm going to keep it there. Okay, tension needs to be broken into x and y. So using the red pen, tension has x component. I'll call that t sub x. And it also has y component. I'll call that t sub y. Okay, so that's the free body diagram. Now, let's sum the forces. So sum the forces in the x, sum the forces in the y. What's the only x force for this problem? T sub x. Now what's t sub x equal to? You don't want to do this. You don't want to go t sub x. Don't do that. You want to put t sub x in terms of t. So what is t sub x going to be? T sine 30. Okay, because the 30 is up here, right? That's the angle they gave us. They gave it to us from the vertical. So t sub x, it's opposite, and then t is the hypotenuse. So it's t sine 30. Any other forces in the x? No. So what is the sum of the forces always equal to? ma, but this a right here is a centripetal. How do I know it's a centripetal? Because look, the center of the circle is over here. There's the center of the circle. Always make the center of the circle positive, like I said. But look, the centripetal acceleration always points to the center. And that's where t sub x points. Now what can we plug in for centripetal acceleration? V squared over r. So we're going to plug that in there. Okay, now go to the y direction. In the y direction, we have t sub y, which is going to be cosine 30 times t, then minus mg, right? So we have t sub y and mg. Those are the two y forces. Okay? Sum of the forces equals ma, but this a goes to 0. Right? Because is there anything happening in the y direction? Is there any circle that way? No. Is there any sort of linear acceleration? No. There's no acceleration in the y, so we can set the y acceleration to 0. Okay? So now, here's what we have. So up here I'm going to plug in, so this is going to become m v squared over r. Okay, so now we have two equations and two unknowns. If you look at these two equations, what are the two unknowns? T and v. If you have two equations and two unknowns, can you solve it? Yeah, and I'm going to show you a trick here. One very common physics trick is sine over cosine is what? Tangent. Sine over cosine simplifies to tangent. So look, I'm going to rewrite these two equations. I'm going to rewrite them. So here we have t sine 30 equals mv squared over r. And then I'm going to write the other one. T cosine 30 equals mg. If you divide these two equations, right? I just put these equations on top of each other and divide them. The t's cancel, the m's cancel, and what's sine over cosine? Tangent. So you got tangent 30 is equal to v squared over gr. All right, I'm out of room, so let's go up here. I'm going to shrink this down. Okay, so we're looking for v. V is going to be square root of tangent 30 times gr. Wait, did I make a mistake here? So this is tangent 30, 9.8, and then the radius is 0.75. So this is how we get the speed of the ball. So what does that come out to be? So this is going to be tangent 30 times 9.8 times 0.75. Yeah, 2.06. So the speed of the ball is 2.06 meters per second. Now, like I said, parts B and C become very, very challenging, and let me just show you why. So first of all, any questions on A? A is definitely on the correct level for this class. Yo. The velocity? Oh, so tangential velocity, like if you're looking at this ball, like when it's right here, if the ball leaves the circle, how does it leave the circle? Tangent to the circular path. That's why we call it tangential velocity. So any questions on part A? Definitely I could give you this on the midterm. Will I give you B or C? No. Do you want to look at why B and C are really hard? And then we'll just stop. Let me just show you why it's hard. So we revert this. Okay, so for part B, theta is no longer 30, right? For part B, this theta, we don't know what it is. In fact, what does it say here? If instead the ball is revolved. Okay, in fact, we're solving for theta for part B. What angle does the chord make with the vertical? So this is what we're looking for. We're looking for theta if the tangential velocity is 4. Okay? Now, is the the length of the string is 1.5 meters. So what's the radius of the circle going to be? It's not going to be 0.75. We're going to call this sine theta 1.5. Right? We don't know what it is. Okay? So when you go to solve this, here's your free body diagram. So mg straight down, tension's like that, theta's right here. So you're going to have to break tension into x and y. So everything's pretty much the same so far, but just wait. So there's tension x, there's tension y, center of the circle's right here. So now sum the forces. So summing forces in the x direction, you're going to have sine theta t equals mv squared over r. And then summing the forces in the y, you're going to have cosine theta t minus mg equals 0. You have to plug in for r. So what's this r going to be? Yeah, r is sine theta times 1.5, and then let's see, divide the two equations. Let's see, how do you, here, this is what I mean. The algebra, the math gets pretty crazy, because look, we have two unknowns still, tension and now theta, right? So do you want to divide the two equations like we did last time? So then you're going to have sine, then you would have tangent theta, and so let's do this. You're going to go sine theta t equals mv squared. Okay, r is equal to sine theta 1.5. Then here's the other equation. Cosine theta t equals mg. So now divide the two equations. The t's cancel, the m's cancel. So sine over cosine is tangent. So you got tangent theta equals v squared over g sine theta 1.5. Guys, how do you get theta? I guess, is there an identity for tangent, sine times tangent? So pretty much I've set this up for you. You guys have fun. Solve this for theta. I'm stuck, dude. I don't remember how to do that. Is sine squared theta over cosine theta anything?
You get 1 over cosine theta minus cosine theta.
Hey, you only have to know part A. Part B and C, the math gets too much. All right, we're done.